Welcome G. Let's start. Today I am going to talk on virtual thread. Before JDK 90, generally since Java started, Java is a multi-threaded programming language. They support thread. Developer can create thread and use. So why this new concept virtual threads come, and these virtual threads are released in JDK 19 as a preview feature. So please we note that this virtual thread is released in Java 19 as a preview feature. Okay, so let's discuss how we can create virtual threads and what are the different way as a JDK 19 language offer us, and we give write some example so you feel comfortable and you are also try to use virtual threads. But surely this is the preview feature, so please try to use for the your learning purpose or knowledge purpose, but generally as Oracle also suggest, don't use in the production. Might be in future some syntax semantics as some methodology can be changed as per the feedback received, but as per my feeling look like there is no any major changes will go to the virtual threads. But we should know how the current JDK 19 have a way to write the virtual threads. So let's jump to the code and look the way you can write the code. So we are in the JDK. So first things how we write the threads. So as you know, to writing thread, what is a thread? Thread means you have some set of Java instructions or code which you want run simultaneously, run concurrently. So generally we write a thread. So those set of line of code you can write in any methods, okay, or you can write inside any runnable task, anything. So let us example we have a like one task void runnable task. Okay, yeah. Here I just write any like logic. Maybe I am a runnable task thread. Let's write what is the current thread name. Okay, so this is the one task, maybe multiple lines. You can say do something, do some processing and done. Maybe start your code, and here you can end. Here you can write your the business logic, whatever doing business. Okay? This logic, whatever your business logic you have. So generally this is the set of instructions you want to execute in a thread. So this method you want to run from your running. So previously before virtual thread concept, generally you can also have an option to create thread. Like a simple way you can create your maybe runnable object, or you can simply create your thread class thread equal to new thread. Okay, and now we have a thread dot start, and after that you have thread dot join. Okay, and here but what the business logic they are going to know, you have to pass this method. So you have to pass here maybe thread or you test as a method reference. So now you can run. Now this program is running in the threads. Maybe you have to run the okay. Now you say this is the start and this is a Let's done. This is your main. Okay. So it's a simple way Java offer you can create a thread in the before JDK 19. And now your main thread is started. Now your sub thread is started. Now your main thread is closed. That's okay. So this thread also known as your platform threads. Internally Java implement these threads as a part of your operating system threads. When you say I want to create a JDK, say I want to create one thread, corresponding operating system, the one specific thread was created. Okay, so now even this thread uh, works as per the only limitations. If your operating systems have some concern, some limited memory, and whatever the operating system support number of threads, only those number of threads you can create, you can schedule. So these are the previously way we are creating a thread. JDK 19, they are not doing any changes here. Say you can your all the backward code works as expected, but you have also create a virtual thread. Virtual threads is also like a thread, like the lightweight threads, super lightweight you can say. They are JDK threads. They are JDK threads. And whenever your threads need to execute on the CPU, at that times these threads are just bind to any OS threads. So might be multiple OS threads are running and huge number of virtual thread you can create, and any virtual thread can run on your any OS threads. So your operating system threads look like your carrier thread, and in carrier threads you can associate any number of JDK threads. So question, how we can create JDK threads or virtual threads? So here the like a simple thread dot just one utility method like of virtual threads, and then you can say on started what is your task, the same test. Let's I want to runnable task. So your unstarted threads, and this is your virtual threads, and here say virtual thread dot start, and after that virtual thread dot join. So there is a no major differences. If you run it, you notice that now the same business logic whatever you have, now you are created JDK thread. Notice previously these are your operating system threads. Now you created a kind of a fork join pools, and this is the worker one threads and one. So these are the threads on which they can run on any platform threads. So if you look the syntax, just you have used the one factory method of virtual, and then on started whatever runnable jobs you have, runnable task you have, you can use. So also JDK for similarity of virtual. Similarly, you can create like a thread dot of platform. That they have are also added one more factory method. Similar way you can create like a say your platform thread. Start join. So there is a thread class are just not modified your constructor, but JDK 19 they have released the two new your overloaded method like off virtual, off platform. Off platform thread look like your platform thread. So whenever you say platform thread, that means ki, JDK are requesting operating system create one thread for me and just associate this task on that, so that our task is run by the your operating system. So notice that if you have created one threads and here you have created one platform threads and just assign this is my task, this my task, and this is the your operating system threads are going to execute. Similarly, this is also virtual threads. So now this is the JDK threads, not the OS thread. And whatever runnable task you pass, they have a one runnable task. But question, how whenever say this is start, at that times they are going to check operating systems have any platform threads. Yes, if any platform thread available, anyone available, just carry put this runnable task on the operating system threads, and now your program whatever you written are executed by the platform thread. Once your task is done, or this thread going to the wait, then this again task come back to your JDK, basically store in their heap memory. So these are the simplest way where you can create the virtual thread. There is no any major drastic changes how developer can create a virtual threads. Just use a virtual method, and you have it also they have a added two more methods here. That's like here thread thread dot. There is a one method like of virtual. Similarly, we have options unstarted like we use or started. So here you can just, and now you can get your virtual thread 1, and you can say virtual thread 1 dot join. So here these threads are created and automatically started. Unstarted means you are creating a runnable jobs and now you have a manually you have to start. Or here say start means just receive the task and start. In this way it's also works. So similarly one more methods added. If someone even want to start virtual thread, the why say start virtual thread than start. Even more simplified version like thread dot directly say start virtual thread, and you pass your whatever runnable task you have. Okay, and you say dot join. Join we are waiting so that our thread can just complete the execution. So more simplified version, whatever your runnable task have, just say start virtual threads. Now your thread is created. That is the JDK threads. Once your code needed, let us example. This is the my code, set up business logics, and this is my operating system, and operating system have a limited number of threads. Your platform threads, platform thread 1, 2 threads. Let's see, we have a 3 threads running in our JDK. Okay, so this our my runnable task, our JVM scheduler can schedule to the any free OS threads. So whatever OS phase threads, they are going to executing some set. Let's assume this is one line, two line. Here we have just invoke some remote web service call or some file item. So here our program is going to the wait. So once our programs, our threads is going to wait, at that times what virtual thread say, just pull out and store again in your heap memory. And what the portion you have completed also store the complete stacks. And now this thread is free. If any others runnable task is doing, then they can assign. Once this execution completed, web service response you receive, then you want to again continue your execution, then again this your thread going to bound any available free OS threads. If the particular this thread is free, just associate here, and now this threads is going to complete your other part. So here the benefit, your one thread task, runnable task, can be executed by one platform threads or two platform threads. If your thread task is going to wait for web service call, for JDBI call, for some file system, for IO operation, your task is pushed out from the platform threads to your heap memory. And once your thread is ready to the execution, again go back. Might be if same threads available free, same threads are assigned, else new threads are assigned. So these are the simplest way you can start virtual threads. And even you can say platform threads as well as. So hope it's a very simple way. And sometimes in our application, so one thing, whenever you are using a thread class constructor, okay, please note that they always create a platform threads. So now JDK 19 onward suggestions, you can use maybe specific factory method like virtuals or off platforms, and you decide you are creating the virtual threads or platform threads, right? So general recommendation, don't use like this manually new threads. They are always create you the platform thread, and you know platform threads have a limitation for each number of threads is the limited depend upon the number of memory available you have, RAM available you have. But for virtual thread there is no any limitation. Your applications, how many number of requests come, for each request you can create the new virtual threads. New virtual thread is managed by your JDK. And once your thread really need to CPU execution, at that times your thread is just map, yeah, mounted to your OS threads. Sometime in our applications also we are using like executor framework. So how we can start services like virtual thread in executor? So executors also JDK 19 added some new factory method, like you notice uh, new new virtual thread. Now you receive a executor service, and here executor dot you submit whatever task, let same task you want to submit, and after that executor start shutdown. So in this way, if you are using any executor service have often key, you don't create manually threads. Executor service will manage all the thread life cycle. Just you pass the runnable task. Any number of tasks you can add. And here previously you are using like a new fixed tail, cache thread pool. So all are the previously your platform threads. Now you have a option, just change your factory to new virtual thread. Now your this task is going to executed by the virtual threads. Okay, so if you are using the manually thread constructor, now suggestion you can use the Thread.startVirtualThreads or a factory method of threads virtual, or similarly if you are using the executor service, just use a new factory method like a new virtual thread per task executor, right? Let us think, sometime you want to create some like a 100 or 1000 or 800 virtual thread. You can create, there is no limitations for the virtual thread, but only limitation was for the platform threads. So let us example, I want to create 100 threads. So how it go? Simply let's say I am going to use into streams, and just let's I want to range 0 to 1000. Okay, and here the map to object, and whatever that's key we have some any thread like say here return thread dot virtual, let's say unstarted, and whatever the business logic you have you just pass, like here say okay, and here say that's Let's get task running. And then here you pass just thread name. Current thread. And here your this return say let's key list to list dot so what is happening here? Let's map to 1000. Map will take us integer some number and it's a to list dot variable. Let's get thread list we have. Okay, so now we have created thousands threads and just say here like something maybe your task maybe let's if let's I double equal to 0 then print this detail. So whatever the logic you want to run you write okay, and even you can say something like thread dot slip and here you can pass duration like let's key off, let's get 2-second delay. Okay, this will need a try catch and your code should be inside here and catch exceptions whatever the exception you have. Okay, so here what I'm going to do here, I just creating thousands of virtual threads and just printing the name of the first threads whatever and sub just will it. And once you have a thread list, just you have to you have here we are using unstarted, so we have to start all the threads. Let's say thread start for each, let's get thread dot start we started all the threads and for this and we have to join all the threads. Thread let's dot join. So here you have created just here created unstarted, then after started and just joining. Now you notice we are creating 1000 threads, just each threads are waiting for 2 seconds. And here you just notice 1000 threads are created. So here thousands are created. Where is so virtual threads started to list start and they just let's print here. They are printing running task. Is there yes, running the business logic. Here you can say your virtual thread just return map to I here thread list thread dot started thread dot joining. Let's comment out this and look the run it, it's working or not. Okay, yeah, this is the task and oh, that is working. I'm just not mention the variable I like here, just mention like I plus so that we should aware. Even you write here without I, you can say thousands threads are created. Right, these are the 1000 threads are created so quickly. You notice here huge number of platform threads. These are the different worker threads. So I am not interested to print all the things, just any random number, any position I want to print. So in this way, the simple way, now you are creating the notice. Here our first, this business logics are printed by your worker thread 1 and they are going to the sleep. Now these are the threads are sleeping. So next times, if you go to the next time, this is printed by your worker thread 5. And if you now different threads are going to this initial business logics are printed by the different threads and this business logics are printed by the different threads. So this is the major benefit of your virtual threads. What virtual threads say? Whatever you're running task is not tightly bound to any OS threads. Now this is your operating system threads, and your threads need a CPU to execute. Okay, so here let's created thousand number of virtual threads. You can create any number of virtual threads, list of virtual threads, and at that time you are not going to increase that number of your platform threads. Once your business logic required CPU, at that time this is just copy and mounted to your platform threads. Now your platform thread execute and returns. Let's see your partially execution done. Again you unmounted here. Once you want to again need a CPU execution, again this complete your virtual threads can again mount it to the whatever number of free threads might be this free here associated, if this free here associated, or this free here associated. So thread mounting, unmounting, due to this concept, JDK offer you can create many number of, as your application read you can create threads. So there is no limitations here. You can number of threads you can create as per number of requests your common system. For per request you can create a different threads. Once your threads are really needed CPU, at that times virtual threads are mounted to the platform thread and platform thread can execute. If your virtual thread going to wait for some times, your virtual thread just unmounted, store in the heap memory. Once again you want to continue, again your same virtual threads again going to the mounted to the any available number of platform threads. So these are the different way where you can create your threads. So hope it's very nice. There is no any drastic changes, but the underlying implementation is drastic changes. Now virtual threads, keep flexible. Your application server, my application server can open per request new thread. Don't worry. So these are the things which JDK 90 offer. As a summary, virtual threads is nothing, just a lightweight or super lightweight, you can say, the threads. This is also thread class extended thread class, but please know, to create the virtual threads, generally use the virtual factory method, or even you can use the start virtual thread directly. Here your threads automatically started. I even thread class also added one more method like is virtual. Can you check the particular thread is virtual threads or not virtual threads? And if you are using the executor service, please use the new factory method like new virtual threads. So these are things for the virtual threads. So one 2 points you have to remember about the virtual threads. Okay, virtual thread is a very super lightweight threads, and you can create any number of virtual thread as per your application needed. If your application needs 1000, you can create 1000 per request. These virtual threads are very light, very super. So there is no any concept you are going to the make a pool of virtual threads. Don't need. There is no needs. And now your operating systems have a limited number of threads. Maybe you can create 1000, 10, 15, whatever number of. Generally, if you have 8 cores, generally 8 threads you can create. But here any number of virtual threads you can create. There is no limitations. And once your application, your threads required a CPU attention, at that times they are going to mount your platform threads, and now your platform threads execute your task on the CPU. Once you're done, unmounted again here. If it's completed, then destroy. If let's see they are partially completed, first mount it to here, partially completed, they want to go into wait your threads, virtual threads. Yes, wait. Now here unmounted here again. Once your program need, again mounted to the available threads. So this is the concept of your virtual threads mounting to the platform thread and unmounting to the platform thread. This is the very simple way from the programmer perspective. Internally, JDK Java designs us have lots of work done, but we have to think whatever the place currently we are using the thread. Now you can use the virtual thread, and virtual thread help us to just don't wait, just asynchronous. So similarly here you very light chances to now your threads are not going to wait or block. Your platform threads are now free, are not going to waiting and blocking for your user request or your business logic processing. Once your business logic required some block or wait, your threads are just unmounted virtual thread. So look like a very streamless asynchronous programming we can achieve from these virtual threads. This is really nice feature. Please try and try to use. So there are some points where your virtual thread might be cannot works. If your thread logic are using two scenario, if your thread are using some synchronized keyword, because synchronized keyword internally implemented to the C and the particular stack trace. So due to that, your thread are not going to mount or unmount. They are directly pinned to your operating platform threads. So if you are using synchronized keyword, please try to avoid kind of virtual threads. Instead of, you can just change your synchronized block to the reentrant lock, and reentrant locks just implemented as unblocking fashion. Some cases where your threads are using some like a GNI call, native interface invoke. At that times, this virtual thread mounting and unmounting not works. So these are some scenario where once your Java threads are going to invoke any native library, any OS native library, GNI call, at that times this interface might be not work. So in the case of synchronized keyword also it's not works. They are not unmounting mounting because your synchronized codes are very tightly to the particular stacks due to that. So they are suggesting please use the reentrant lock in the place of synchronized keyword. Okay, so some plus minus, but each have. Please go to the your virtual test details, and if you have any doubt concerns, please write the comment. Surely I'll again connect or reply or write another separate video for that. Thank you for watching this video.